So the third aspect of Rx, and really what makes it one of the more fascinating things that I've ever seen, is this notion of schedulers. It's the kind of the how, what, and where of things actually happen. So it's kind of the key questions you want to ask are, well, where am I going to run a timer, for example? How am I going to run it? Where am I going to produce the events? And how do I need to synchronize with the UI? So one of those is very much on point. So, for example, if you're doing animations, for example, if you're doing animations, you're going to probably want to use request animation frame. Well, to do that inside of Rx, you can do that by just putting in the request animation frame scheduler, and suddenly every operation that you're going to do is going to be done via a request animation frame callback. You could do it set timeout, where it's only going to use set timeout as its scheduling mechanism. When it needs to synchronize with the UI, for example, in Angular of all places, there's kind of this digest capability where you can kind of tell within a particular scope that, hey, you can update the UI. Well, to do that, you can use, once again, a scheduler to basically say, take this one particular action and apply it during a given scope. And we're going even further in the future, where we can start to say web workers and so forth can be done over schedulers. That work's kind of started, but the idea is taking the entire expression tree, sending it over to a different machine, calculating the result, and sending it back. We have the beginnings of the parser there, hopefully before too long. So really, schedulers are the answer. They introduce the concurrency model. Operations, any operation can be parameterized. I can go from immediate to timeout to request animation frame to whatever I want to at any point in the calculation. And this also kind of provides us testing benefits as well, because now, instead of having to being tied to a concrete thing such as set timeout, I can swap it out for a complete virtual time to say, well, I'm going to run things through historically, or I'm going to start testing. So you kind of get this many implementations of this schedule. And you also get, once again, the cancellation beauty that you had before. So that cancellation goes all the way down into the deep core of Rx. So when I cancel something, it goes all the way into the scheduler and cancels it. And it also makes testing your code very, very easy. So, for example, all of our code in Rx is written exactly kind of this way, which is we can create a test scheduler. We can kind of create a sequence at 300, 400, and 500. They yield values. 300, it yields applicative. At 400, it yields 2015. And finally, on 500, it calls uncompleted. So basically, it's just a thing that yields two values and says it's done. So what we can do is we can pluck the length from there, and then we can absolutely assert that on next, at 300 ticks, we have a length of 11, and at 400 ticks, we have a length of 4. Every single time. We don't have to do any async testing. We don't have to do any waiting for timers, nothing. Because of the fact that we can rip out basically your concurrency model, it becomes that much more testable. Now, reactive streams is another interesting aspect that people are starting to get into, which is it's trying to solve reactive programming for the JVM in particular, but it has some very interesting questions. For example, how do I deal with things like back pressure? Because when you're dealing with, say, Rxjs on the server, which it works quite well, how do I deal with the fact that, for example, I'm capturing all of this user input, whether it's stock ticker updates, GPS feeds, whatever, but my end source, say, my database just can't keep up for whatever reason. We have kind of some of those answers already, whether they're lossy or lossless. So, if it's lossy, I could say it's pausable. I could pause and resume. I can sample it. I can throttle to bounce. Any number of those kinds of things where I just don't care if things are dropped on the floor. And in fact, you can also be lossless as well, as to say that I'm going to say buffer with a time of, say, 5 seconds. So give me everything that happens within 5 seconds. Great. Anything that happens, limited to 100 events at a time. Great. I can do that too. And then possible buffered is the idea is that you can pause and resume, and then when you call resume, all of those that buffer gets emptied, and you're good to go again. And the idea behind controlled is the fact that you can start requesting n number of items directly from the observable sequence. So that kind of brings up another thing, which is async await. So async await is a thing that's coming to JavaScript, we hope, at some point. But it adds async and await for promises, and it's already been accepted into stage 1 at least for ECMAScript 7 or whatever we want to call it now. Jafar can probably comment on that. But the idea here is that we can start to go through and await each individual animation as they happen. But guess what? We can already do that with Rx. We have this idea of rx.spawn. So in ES 2015, we have this notion of generators. Really cool stuff. Highly recommend that you read up on it. And so anytime that you have a runtime with generators, we can already say, like, get applicative, yield get applicative, try it 3 times, and if there's a failure, just return me a cached version. We're good to go. So that's available today in any environment such as Chrome, for example, and IOJS that support generators today. So you can get that kind of async-y, await-y kind of feel to it. So it makes your program just seem a little bit more linear than it is. And yes, and there's a good reason we had him here as well, is because async generators is another interesting aspect of where things can go with observables. So you could imagine, as it were, that observables are built right into your runtime. So any mouse downs, mouse moves, and mouse up are just built right into your particular runtime. How cool would that be? Is the fact that I don't have to worry about wrapping all of these sorts of things, but then I can just kind of build on top of it, which would be really, really cool. So, in order to really kind of learn Rx, there have been many great tutorials out there. Andre out there has a great post of basically, the introduction to Rx that you've been missing. Just because sometimes our documentation can be rather dense and MSDN-like, we want people to be able to basically understand at that deep core level that all you're learning is just regular functional programming over data structures and no more. So this Learn Rx that Jafar has worked on is a way that you can start with arrays and start to do with map, filter, concat, reduce, and zip. And then what you can do is then you realize, well, I'm going to turn it on its head and start using observables in just the same context, and you're good to go. So it's been a very, very helpful learning tool. I've used it quite often. Netflix uses it. It's been a wonder. Just as well, like I mentioned earlier, Rx Marbles is the site where basically if I wanted to see how an individual operator actually works, I can look and see, well, if we have merge, what does that look like? And here what we have is we have these values here that as they're coming along, you'll have another stream that also comes along. And how does the merging actually happen? Well, this kind of shows you exactly how it works. Now, if you want to find a particular site where you can see that Rxjs is really in action, I mean, you can't really look at, say, your Netflix player and just take a look at the code, but you can for Sweet.js. So Sweet.js is a kind of a macro tool for JavaScript, and if the editor itself is written in Rx. And so any of the key bindings, any of the window resizes, all of those things are observables. And so I highly recommend you to take a look at go to that site, and then go and take a look at the source code. Because the source code has so many really cool things about it. So, for example, on document ready, we can initialize the key maps by turning that into a stream. We can initialize the output and the output options by turning that into a stream. So it's all about all of these particular things and setting up the code mirror so that both sides start to do it. So you got zip, zip. So you got one side and the other side, and they're both synchronized. And you're just using the functional programming concepts that you already know and use today. So what about the libraries that I'm already using? Now, that's always been a question. Does Rx replace everything that I've ever done? And the answer is no. Rx, in fact, what we try to always say is it's kind of your glue or your duct tape, as it were, depending on how handy you are, to really build your rich applications. I mean, yes, you can build your entire application out of Rx itself, but you could also mix it in with React, with Dojo, with Backbone, jQuery, Angular, Ember, and so forth. And with Backbone, jQuery, Ember, Zepto, and so forth, you get kind of that behavior for free, because when you call from event, we automatically look and see if the element that you passed in happened to be from jQuery, Angular, etc., and use those native bindings versus going directly to the DOM. But we also have community-driven libraries such as RxJQuery, RxAngular, RxEmber, RxDojo, and so forth. And even, as I'll show you in just a second, even a lot of RxReact particular things that are really, really cool. So Rx in a virtual DOM world actually makes a lot of sense here, because when people start to think about React and they're thinking about unidirectional data flow, you really can't say React without saying Flux at the same time, just because you're talking about this sort of this kind of backend architecture of how you get how you get your data, how you persist data, and so forth. And that's an absolute perfect thing for things to do. So check out some of these projects minus async React. Hint, hint. But once again, it's also very interesting. There's another project called Cycle, and so Cycle is from Andre here out in the crowd, and the idea here is it's reactive MVC, but it's with the model view intent architecture. So basically, the intent is a component whose idea is to translate those user events into, say, model friendly events. So it translates those view like idioms into model idioms. So it's kind of that translation layer, as it were, and just to make sure that it actually does what it does. So the model basically exposes, for example, the name changes in this particular example, and then in our view, we're going to listen for those name changes, and then basically from there, we're going to start to render a div and label an input field and say hello someone. So that, to me, holds a lot of promise for a fully deep-down reactive MVC kind of thing. So I've got a few demos to run through.